Okay, this is that lesson from Algebra 2 that none of you guys really like too much. We're going to talk about today solving systems of equations with three variables. Okay, so we're going to have an x, y, and a z. So examples, what are systems with three variables? We've got our x, y, and z variables here. Okay, hopefully this is starting to kind of ring a bell a little bit from when I had you guys in Algebra 2. Like I said, these take a lot of work. We kind of use a combination of substitution and elimination to solve these kind of things. Let's run through our rules for our strategies on how we're going to break these down, and then we'll come back and we'll take a look at these. So, first thing we're going to do is we're going to pick a pivot equation. Okay, and this is important. Your pivot equation should be one with a variable that's by itself. Okay, meaning that I have just an x, or I have just a y, or I have just a z. And then I'm going to use that pivot equation. I'm going to multiply that pivot equation twice, probably by two different numbers. Okay, and I'm going to multiply that so that I eliminate one of the variables. Okay. I'm either going to try and eliminate my z's or my x's or my y's. But what's going to happen when I eliminate, okay, one of those variables is it's going to give me something that's going to be like, say I eliminate my z's, it's going to be an x and y equals something and an x and y equals something. So once we get it to that point, we've created a system of two equations with two variables. And if I have my systems of two equations with two variables, we know that we can use substitution or elimination to solve those. Okay? And we're going to use our substitution or elimination to solve for two of the variables. Then once we know two of the variables, we can simply plug those two values back into any one of the original three equations to find our third, and then we've got our answer. Okay? So let's look back at those original ones that we started with. Okay, I've got a negative 5x plus 3y plus 6z equals 4, a negative 3x plus y equals 5z, plus 5z equals negative 5, and a negative 4x plus 2y plus z equals 13. Okay, if I'm looking at this one, this equation right here is not going to be my pivot equation. It's got a 5x, a 3y, and a 6z. None of those are by themselves. Okay? If I'm looking at it, I see a y that's by itself. I could make this its pivot equation. Or I see a z by itself. I can make that my pivot equation. And honestly, it does not matter which one you make your pivot equation. Okay? So, for example, on this, if I have, let's say I make this my pivot equation. Okay? Then I'm going to be eliminating my y's because that y is by itself. So let's say I want to eliminate my y with this one first. Okay? That means that I would have to take this equation here times a negative 3. So that way I'd have a negative 3y, and I could eliminate those when I added those two equations together. Okay? So that would be the first thing that I would do to eliminate my y's. Then I'd have to come back a second time, and this is still my pivot equation, but I would need to eliminate my y's with this equation here. So I could take this equation times a negative 2, and that would allow me to eliminate my y's. Okay, and then once I do that, it's just substitution or elimination with the two new equations that I've created. Okay, hopefully that helps you guys to figure out how to pick your pivot equation. If I went over to this example here, this example has two different ones that could be great pivot equations. This one could work as a pivot equation. It would be your x, okay? Or this equation could work, and you could eliminate your x's or you could eliminate your y's. Let's say I picked my top one, okay, for my pivot equation. Well, the first thing I want to do is I'd need to take this times negative 1 to eliminate my x's there. And then I'd come back to this same equation, and I'd want to take it times a negative 2 to eliminate my x's there. Okay? Hopefully that kind of helps when you guys are trying to figure out your pivot equation, because picking the right pivot equation is huge to finding your guys' answers. So let's actually go through and work out one of these then. I've got a 3x plus 2y minus z equals negative 15. 5x plus 3y plus 2z equals 0. A 3x plus y equals plus 3z equals 11. Okay, again, middle equation, not a good pivot equation. None of them are by themselves. Bottom, I could do as my pivot and I could eliminate my y's. Or top, I could do as my pivot and I could eliminate my z's. Now, I'm going to pick my top and I'm going to eliminate my z's. Only reason is this one's already negative, so I'm not going to have to worry about changing any signs. Probably going to take away some tiny mistakes that I could make. So top one's my pivot equation, which means I'm going to take my 5x plus 3y plus 2z equals 0. And I'm going to use my pivot to eliminate my z's. And then I'm also going to take my 3x plus y plus 3z equals 11. And I'm going to eliminate my z's with that one as well. So starting out, this one is my pivot equation, and I need to eliminate my z's. I've already got a negative z, so I need to take my pivot equation times 2. Okay, if I take that times 2, that gives me a 6x plus 4y minus 2z equals a negative 30. Okay? And you guys can see I've set this up now so that when I add these together, I've eliminated my z's. 2z and negative 2z would cancel. I'm left with 11x plus 7y equals negative 30. So I eliminated my z's with my first two equations. Now I need to go to my second equation that I have, the 3x plus y plus 3z equals 11. Okay, so I need to change my pivot again, and this time I need to eliminate a 3z. So I'm going to want to multiply my negative z times 3. When I do that, I have to multiply the whole equation. That's going to give me a 9x plus 6y minus 3z equals 3 times negative 15 is negative 45. Okay, and again, I have set up so that I can eliminate my z's. Okay, 3x and 9x would give me 12x. Y and 6y would give me 7y. And then 11 and negative 45 gives me a negative 34. So what I've done now is I've created two new equations. I've got an 11x plus 7y equals negative 30. And I've got a 12x plus 7y equals negative 34. Now these two equations here look like what we were doing with our first two lessons of this, of substitution and elimination. Okay? So I can go through and I can either do substitution or I can do elimination to solve for my x and y's. Now, I'm going to want to do elimination because I see a 7y and a 7y. The only thing I'm going to need to do is I'm going to need to take this top equation times a negative 1. And when I do that, that gives me a negative 11x minus 7y equals a positive 30. So now I'm set up to eliminate. Okay, 12x and a negative 11x gives me just an x. My 7y and negative 7y cancel. And negative 34 and positive 30 gives me a negative 4. So I find my first variable. I find x equals negative 4. Now remember, I'm just using these two equations right now. I'm just solving for elimination. So I found my x. So my next step is to plug back in to one of these two originals. It doesn't matter which one, and solve for my y. Okay, so if I do that, I'm going to take my x and I'll go 12 times negative 4 plus 7y equals negative 34. Okay, 12 times negative 4 gives me negative 48 plus 7y equals negative 34. I've got to add 48 to the other side to cancel, and I get 7y equals 14. And then divide both sides by 7, and I get y equals 2. So now I've solved for two of my variables. I only have one variable left to solve for. So x equals negative 4, y equals 2. Well, I can go into any one of these original equations here, and I can plug in the x and y values that I know, and then I've only got the z variable left to solve for. So let's go back to my pivot equation. I'm going to have 3 times x, but instead of x, I'm going to have a negative 4, plus 2 times a 2 for my y, minus z equals negative 15. Okay, 3 times negative 4 gives me negative 12, plus 2 times 2 gives me 4, minus z equals negative 15. That gives me a negative 8 minus z equals negative 15. Add my 8 to the other side, I get negative z equals negative 7. Okay, I've still got the negative in front of the z. I need to get rid of that. I can divide both sides by negative 1, and I get z equals 7. So my final answer on this, okay, the way they want you guys to write these is they want you to write them as an ordered triple, okay? And an ordered triple, you're going to put your x first, then you put your y value, then you put your z value. So I've got negative 4, 2, 7, okay? And that is solving a systems of equations with 2 variables. I think I just said with 2 variables. I meant solving a systems of equations with 3 variables.